Coding made easy.
So what's up everybody, and welcome to your third Algorithms Made Easy tutorial. And in this tutorial we are going to be learning about the selection sort algorithm. And this algorithm is still classified as a big O of n squared, but it is slightly more efficient than the bubble sort. So a question you might be asking, okay, if it is the order of n squared, sorry about that, I got a text message, but you might be asking, okay, if it's order of n squared, for somebody who isn't totally familiar with big O notation, if they're both the exact same, then shouldn't their efficiency be the exact same? And the answer is not exactly. Okay, for example, say for example, we have this mathematical equation. We have 10n to the power, to the power of 2, and we have plus 40 plus 5 to the end is equal to so on and so value, right? And whatever the value is, right? And once we get to higher and higher values, we sort of realize some certain things. For example, let's just say that n is equal to 10, right? So 10 to the power of 2 is equal to 100. 100 times 10 is equal to 1,000, and then we say 1,000 plus 40, and then 5 times 10 is 50, so we get 1,090. And so if we were to take, I think that's what the answer is, whatever. So if we were to take 1,090, subtract 40 from it, we get to 1,050, and we start realizing that the higher n becomes, the less significant 40 is. And so if we're looking at this in terms of the mathematical equations of the algorithm, we only want to look at what is the most significant part of that algorithm. And so as n increases, we notice that right here, n squared. So so as n increases, we get this is more significant. It has the greatest effect on the actual total of this mathematical equation. So although when we say order, whenever we say the big O or the order of or something, it just means that this area of the algorithm has the biggest effect on the outcome. So in terms of saying, just by saying that order of n squared, yes, the bubble sort and the selection sort are both order of n squared, because the most significant, or the equation that has the most effect on it is n squared. But in terms of the operations going on and the number of operations going on in the loops, it is slightly faster than the bubble sort. So just to give you a gist of how it actually works. So let me just get my tablet, my pen here. And so this is how the selection sort works. So with the bubble sort, we compare two, swap them if they need to be swapped, compare the two, swap them, and yada yada yada. The way the selection sort works is that it traverses through each of the indexes or the elements in the array, and then it finds what the minimum value is, and then based on what that is, it places it in the right spot. So first we want to find the minimum value that goes into this one. So we set the minimum value to 10. So we check, we say, okay, is this value less than 10? Okay, that's we say, okay, well, we're gonna set the minimum index or whatever to 4, and we go and check here, is 11 less than 4? No, it's not. Is 5 less than 4? No, it's not. Okay, so this must be the lowest value, so we must put in this spot. So we take this and put it in this spot right here. So we end up getting 4, 10, 11, and 5. And so we already know that's in this place is the set position, so we start checking from here. We say, okay, this is the minimum value. Is 11 less than 10? No, it's not. Is 5 less than 10? Yes, it is. So we're going to set the minimum value to 5. And there's nothing else to check, so that means this must be the second element to put in. So let's swap these two. So we put in 4, 5, and then we have 10, or sorry, 11, then 10. Goes through it again, but since it's already said, it checks this one. Okay, so is this one less than this? Is this less than that? Yes, it's true. Okay, swap them. And so we have our final array. Okay, so let's see how we're actually going to do this in code. So let's get rid of this and let's minimize this right here. So I'm gonna create a new sort and we're gonna call this the selection sorts. So we're going to take the same parameters. So we're just passing in the array and the array size. So what we want right now is we're going to just create a variable called min. And so we're going to create a loop that loops through the size. And then we are going to set minimum equal to I. And so we're going to have another loop. And we're going to say, sorry, j is going to be equal to I and j is less than size. So what we want to do now is, for this top loop we're traversing through the whole array, and in this one we're looping from where I is onward to the rest of the array. So what right now we've set the minimum index, we've set the minimum to what I is, so we're setting the minimum to 0. So if we check this right here, index 0 is 10, so that's the minimum value. So now we have to say, we're gonna say if temporary j sorry about that, temporary j is less than temporary minimum. If it's less than minimum, then we're gonna set minimum equal to j. So does that make sense? So what we're basically saying is, we're saying, okay, for right now, j and minimum, they're both the exact same. So let's go to the loop again. So we're going to say j plus equals 1. So we're going to say, okay, is this one less than this one? Okay, so if that is true, then we're going to set minimum equal to this index right here. And so we're going to check j again. We're going to increase j again. And then we're going to say, okay, is j less than the next element, and then it's going to check the next element and the next element until it gets that minimum value, and then we're going to do the exact same ending as we do with the bubble sort. So after it's done all this and we actually get the minimum value, then let's just open up our bubble sort and let's just take this from here. So we're going to make a few changes, but well, actually, you know what, it's better that we type it out. So outside our nested loop, we're gonna say, okay, we're gonna make a temp, and we're gonna say our temp is equal to temporary I, and then we're going to say our temporary I is equal to that minimum value. So temporary minimum, and our temporary minimum is equal to the temp value. And then so after that, that should actually sort it. And then let's actually take a look right here. So we're gonna, instead of bubble sort, we're gonna put selection sort, see if we did everything right. Let's run this. And so this is the random values that it spewed out, and it arranged it from the lowest all the way to the highest. value. And so we can, again, just the same thing as we did with the bubble sort. Instead of checking if it's less than, we can check if it's greater than, and run this again. And then it organizes it from the largest to the smallest out of all the numbers that are given to us right here. So just to kind of review what goes on, so what it's basically doing, it says, okay, we're going to set the minimum value to the first index right here. Okay, so then it's going to check the next index. It's going to say, okay, is the next index less than this index? Yes, it is. Okay, so we're going to set the minimum value for the index at index number 1. We're going to check the other two. We realize that this is the smallest one, so let's take this and put at the first one and then switch this one over here. So we already know that number 4 is in the correct spot, so we don't need to check that correct spot anymore. So now we're going to start checking from spot number 2 right now. So we're going to say, okay, it's going to check against itself obviously at the beginning, so it's going to say, is this less than this? Obviously not, everything stays the same. So is this less than this right now? Is this less than this? No, it's not. And it's going to say, is 5 less than 10? Sorry, I should be checking this. So is 5 less than 10? Yes, it is. So we're going to set the minimum index to index number 3. And since there's nothing else to check, it says, okay, so this must be the second element. So let's take this, put it here, and swap this one with there. And it continues doing that until we have a fully sorted array. So anyways, that's it for this tutorial. I hope you enjoyed it. Don't forget to comment, rate, and subscribe. Don't forget to like on Facebook. Don't forget to follow on Twitter and sign up on my website for source code and other features. So that's it, and bye for now.